In this video, we're going to be graphing the line of a linear equation given in point-slope form. So let's go ahead and take a look. Let's say we have the equation y minus 1 equals 3 times x plus 1/2. Okay, so this is a linear equation given in point-slope form. And we're going to need a few components out of it to graph a line. So let's go ahead and remind ourselves the components of a line or an equation in point-slope form. So we have y minus y naught equals m times x minus x naught. Okay, so what we need is these three pieces of information, where m is the slope and x naught and y naught are the coordinates of a point that's somewhere on the line. So we can identify these by looking at the point-slope form. So we have the slope of 3. We can identify the slope right here is 3, that's m. And then we have 1/2 right here and 1 right here is our x naught and y naught. But we need to be careful because it's going to be the opposite sign that's actually in our equation. Because remember, it's y minus. We have a minus y naught and a minus x naught. It takes on the operator. So actually our point right here is a minus 1/2 and a positive 1. So we do need to be careful when we're dealing with our point here, our coordinates, because in the point-slope form, it's actually a minus y naught and a minus x naught. So we need to be careful with that. But now that we have our slope and a point, we can actually go ahead and graph this thing because we actually know how to do this. So we know a point on the line is going to be at minus 1/2 and 1. So right here is going to be a point on the line. And what we want to do is we want to find, using the slope, we want to graph this line. So with every move up 3, we're going to go to the right 1. Slope is 3 over 1. So 1, 2, 3, and 1. And it keeps on going. So it goes through that point right there, right here, and it keeps on going in both directions. So there is our line. It goes forever in both directions. And if it helps, we can rewrite the slope as 3 over 1. I like to use the slope as a fraction because we can clearly see the rise over run. Okay, let's do some more examples of this. Let's say we want to graph the equation y plus 4 equals 2/5 times x minus 1. All right, so we need to pick out a few pieces of information. We need the slope. Our slope m is right here, it's 2/5, and we need a point. So we have the point right here, the coordinates x naught and y naught, but it's going to be the opposite sign. So our x coordinate is going to be a positive 1, our y coordinate is going to be a minus 4. Okay, recall about the point-slope form to see how we actually got those signs. So let's see, we have a point 1 and 1, 2, 3, 4. So a point on the line's right here. We already have our rise over run, so from right here, we can go up 2 and to the right 2. So go 1, 2, and 1, 2, 3, 4, 5. So a point right there is on the line, and it actually keeps going. And we do the same thing in the opposite direction, making it as straight as possible. And that is our line for our equation. Okay, not a whole lot to it. We just want to be careful with our signs and just be careful in general when we're actually deriving some information from our point-slope form. All right, so let's look at some more. Let's say we have the equation y plus 1/2 equals 5x. Okay, so we're going to need the slope and a point. So the slope is going to be right here. It's going to be 5. It's the term in front of x. And we're going to need a point. Now, there's no x naught over here, so we know our x coordinate is going to be 0. Okay, so it's technically like this, but we just have 5x and we don't write the 0, so it's actually just a 0 for the x coordinate and a minus 1/2 for the y coordinate. This is actually going to be our y-intercept since our x value for this point is 0. So let's go ahead and graph this. So 0 and 1/2. So the line's going to pass right here and has a slope of 5. So if you want to write the slope as 5 over 1, to make things a little more clear, we're going to rise 5 and go to the right 1 space. So we have 1, 2, 3, 4, 5, and 1. So it's going to go through the point right there, and it's going to go in both directions. Okay, not a whole lot to these. We're practicing graphing the line of an equation that is given in point slope form. All right, let's take a look at the next one. We have y minus 7 equals minus x plus 2. All right, we're going to need the slope and a point. Here, be careful with the negative sign. We actually have a -1 as the slope. The 1 is understood, but instead of distributing this minus sign, we're just going to keep it like this and identify the slope as a -1. So our slope is -1, and our point is -2 and +7. Okay, our x-coordinate and our y-coordinate. We're going to take the opposite signs. All right, let's go ahead and we can write our slope as -1/1 or 1/-1, however you want to look at it, whichever direction you're looking at it. And we can graph this thing. So a point on the line is -2 and 7. 1, 2, 3, 4, 5, 6, 7. So it's going to go through this point right here, and we're going to go up 1 and to the left 1. Up 1 and to the left 1. And we're going to do it in the same direction. We're going to do down 1 and to the right 1. We're using this one. So as long as that's not on line. So as long as we're getting the correct slope, doesn't matter which direction we go, it's going to be correct either way. You can see that this is definitely trending down, so we have a negative slope. So that gives us a hint that we're indeed doing it correctly. And it's just a light descent, so because this isn't a very big number, so that is the correct slope here. So let's take a look at, let's do a couple more. Let's say we have the equation y equals -1/3 times x plus 3. Okay, now this actually looks like a combination of slope-intercept form and point-slope form, because y is solved for, which makes us think slope-intercept form, but we have x over here in parentheses, which makes us think point-slope form. This is actually a point-slope form, but our y-coordinate, our y-naught coordinate, is 0. So we want to watch out for that. We have our slope here of -1/3, and we need a point. We have a x-coordinate right here of -3, and our y-coordinate is 0. Y minus 0 is just y, so it's just not appearing here. All right, we have our slope already in fraction form, which makes things simple. So we have a point on the line of -3, 0. So we have a point right here, and we can go down 1 and over 3, if we want to think of it like that. So for each descent of 1, we go to the right 3. So 1, 2, 3. It goes through that point right there on our y-axis, and it goes in both directions. And if we just use a straight edge, we can get this thing as straight as possible. And always put our arrows on the end to identify that this indeed goes forever in both directions. All right, let's take a look at y plus 3 equals 2 times x minus 5. X minus 5. Okay, we need a slope. Slope is right here, 2, and we need a point. So we have the x value of +5, and we have a y value right here of -3. So we know that this line, the equation, this line that's defined by the equation right here, goes to the point 5 minus 3 with a slope of 2. So let's find the point 5 minus 3. So 1, 2, 3, 4, 5, and 1, 2, 3. So it goes to this point right here and has a slope of 2. So we're going to go up 2 and over 1 in the positive direction. So 1, excuse me. We're going to go, let's rewrite this as a fraction, 2 over 1. We're going to go 1, 2, 3, 4, 5, 1, 2, 3. So we're going to go up 2 and over 1. up 2, and over 1. And that's basically, it's pretty simple to graph these. As long as we have the correct information, graphing is actually just pretty simple. Let's go ahead and squeeze in one more. Let's say we have the equation y plus 5 over 3 equals 2 over 3 times x minus 4. X minus 4. That's ugly, and I apologize. So here we have the slope. So we have the slope of a positive 2 over 3, and we need a point. This is minus 4, so our x-coordinate is a plus 4. We're taking the opposite, and the opposite of the y-coordinate is a minus 5 over 3. And we're getting this by the point-slope form. The point-slope form is a minus y naught, so we're essentially subtracting a negative 5 over 3, and we have a negative x naught, so we're essentially subtracting a positive 4 here. Or subtracting a negative 4 here, which keeps it positive. Okay, so this is a point that the line goes through. So the line goes through the point 1, 2, 3, 4, and minus 5 over 3, or minus 1 2/3, which is about right here. So the line goes through this point, goes in this direction, and it goes in this direction. Put our arrows on the end, because it goes infinitely in both directions. And there you have it. So we're running out of time here, but we're graphing the lines of a linear equation given in point-slope form. And all we simply do, it's actually pretty simple graphing these equations, because our slope is here, and we're given 2 points already on the line. So especially when we're graphing linear equations, point-slope form is very useful because we know a point to start from, and we know the slope, so we can go from there. It's just another way of graphing, and I find it very simple. So look over this a few times, and remember that we're taking the opposite of these two coordinate values. So that's the only trick here. We want to take the opposite of these two values because they're being subtracted. So practice this a little more, and I'll see you soon.